Okay, so I haven't done an algebra problem in a very long time, I think quite a few months, so I thought I would give one a shot. So we have here the square root of 6 to the 11th plus 6 to the x over 6 cubed plus 6 to the x equals 36. Okay, so a couple things I want to deal with right away. Now, everything here is a 6, and 36 is 6 squared, so I think I'm going to be more comfortable if I write this 36 as 6 squared. And then what I can do is square both sides to remove this radical. So on the left side, we're going to have 6 to the 11th plus 6 to the x over 6 cubed plus 6 to the x. And then squaring this, we'll write this as 6 to the 4th. Then from here, what I want to do is cross multiply. I'll just create like a 1 right here so I can do my cross multiplication so I don't have this kind of awkward fraction on the left. We'll multiply the 1 in here, and we're going to have 6 to the 11th plus 6 to the x. Multiplying 6 to the 4th times 6 cubed, we get 6 to the 7th. And 6 to the 4th times 6x, I'm just going to leave it that way for now and write it like this. And what I would like to do is I want to get these are just numeric values, and then these have x. So I want to get them on the same side. So in other words, what I want to do is get my 6x here and get this over here. And I can do that by subtracting a 6 to the 7th on both sides, and over here, subtracting a 6 to the x. Now let me just clean that up to see what we have. So on the left, we're going to have 6 to the 11th minus 6 to the 7th, with this canceling. And on the right side, this cancels here. We're going to have this term, we'll have 6 to the 4th times 6 to the x minus this one, 6 to the x. And then what I can do is factor out my common terms. So like here, we'll factor out a 6 to the 7th. 6 to the 7th times, factoring 6 to the 7 minus 6 to the 11, we're going to have 6 to the 4 minus 1 on the left. And here what I'll do is we'll factor out a 6 to the x, and we have 6 to the 4th minus 6 to the 4th minus 1. And the good news there is this and this are the same thing. So essentially we could divide both sides and cancel these out. Clearly this is not 0, so we're not dividing by 0. We'll cancel those out. We're left with 6 to the 7 equals 6 to the x. But because we have the same base, we can just equate the exponents. And that's going to give us our solution. We're going to have just x is going to be equal to 7. Now let's take this answer and see if we can just validate it real quick by plugging it back in here. So in our numerator, we're going to have 6 to the 11 plus 6 to the 7. Here, I'm going to write this first. We'll have this as 6 to the 7 plus 6 cubed. We want it to equal 36. Now, what I can do, what can I do? From here, we'll just factor out common terms. So I'll factor a 6 to the 7th out from the numerator, and we'll have 6 to the 4 plus 1. And then here in the denominator, we'll factor out a 6 cubed, and we'll have 6 to the 4 plus 1. That's pretty convenient because this is going to cancel. Okay, well, we're square root, but this, if we cancel 3 of these into here, we're going to have, this is going to be 6 to the 4th. But the square root of 6 to the 4th is going to be 6 squared, and that's just 36. So that matches that, and we're good. So that's it. Thought it was a fun problem. I got this from a new quiz I did. It's called, what's it called? I think it's called Roots, and I don't remember what it's called. I'll leave a link in the description though. There's a bunch of problems like this if you want to try some. Check it out. Thanks everyone for watching today. Have a good day.